Welcome to Study Loop.
Here we're going to use conservation of energy to estimate the temperature rise in a nail as it gets impounded by a hammer. And so the nail is doing work on the hammer because it is changing the kinetic energy of the hammer. So the idea is there's negative work being done on the hammer, and we can figure out that work using the work energy theorem. Okay, so the change in kinetic energy is basically the final kinetic energy minus 1/2 the big mass of the hammer times its speed squared. Okay, and we can figure that amount out just for fun. And we are actually going to do 10 hammer strokes. So we're going to go ahead and multiply that number by 10 to get the work done in joules. Okay, the question is, where does all that energy go? We are going to assume that the energy goes into the internal energy of the nail, all of it. That is a little bit misguided assumption, but otherwise we'd have to model weird things like radiative cooling and conduction, etc. So we're going to assume all 338 joules go to changing the internal energy of the nail. And that we can figure out the temperature rise by relating that increased internal energy to the mass of the nail times the specific heat of its material times its temperature change. And so, let's see. The mass is, okay, so we have 338 joules, and the mass is 0.014 kilograms. The specific heat of iron, you can look it up, and it is 450 joules per kilogram degrees centigrade. And we're after that temperature increase. So kind of working it out, dividing both sides by the 0.014 and the 450, we get a rather large temperature increase. Okay, so delta T, just take those numbers and work out the cross multiplier. And the answer will be in degrees centigrade. And it is a little over 53 degrees centigrade. So that's really quite surprising and points out that this is probably not what happens to that nail.